Hi class, welcome to lesson 3.2a, components of vectors. We'll be spending a couple days on the components of vectors and we're breaking it down into two different parts. Okay, so let's take a look at what we have here today. Any vector can be resolved, this is a new term, into its horizontal and vertical components using trigonometry. So we're going to be using SOHCAHTOA because we have a right angled triangle. Okay, and the vector is like the hypotenuse, so it's also called the resultant. Okay, and then you're going to have your horizontal component, which is x, and your vertical component, which is y. All right, let's take a look at an example here, guys. We can use. Okay. Example 1. A truck is driving 120 kilometers in the direction of north 35 degrees east. Draw a diagram with its velocity and horizontal and vertical components. So first of all, we need to realize that we're going to start somewhere down here because we're going northeast. Okay? So from my starting point here, ladies and gentlemen, I know that we are going north 35 degrees east. So the 35 degrees comes from this angle here. My magnitude of it is 120 kilometers per hour. In order to get the vertical and horizontal component, I'm going to drop a 90-degree triangle like this. Okay, and then what we need to do is figure out, hey, what's this interior angle? Well, we know between north and east it is 90 degrees, so if you take 90 degrees and subtract 35 degrees, that equals 55 degrees. So my interior angle that I'm going to use is 55 degrees. Okay, and this is y, which is my vertical component, and this is x, which is my horizontal component. Okay, so that's how you draw, showing your vertical and horizontal components by dropping and creating a 90-degree right triangle. All right, now it says B part, determine the magnitude or the magnitude of the horizontal and vertical components. All right, let's deal with the vertical first. Okay, so looking at the vertical, ladies and gentlemen, I'm looking at y. Okay, so y is my vertical component. Okay, so what do I know? I have information in my angle. So my angle of reference is 55 degrees. I want what's called my opposite side, and I want here which is called my hypotenuse. So according to SOHCAHTOA, what ratio am I going to use to help me sub that in? And hopefully you realize that's the sine law, or sorry, the sine ratio. So what do we know? We know that it's going to be the sine of that angle, 55 degrees, equals the opposite side, which is y, over our hypotenuse, which is 120. Okay, to get y by itself, you cross multiply, so y equals 120 times the sine of 55 degrees. So y equals 9.8 rounded. Okay, so therefore the vertical component is 9.8 kilometers per hour. All right, let's take a look at doing the horizontal component. Okay, the horizontal component is the x. Okay, looking at our angle of reference, which is 55 degrees, I have the adjacent side and the hypotenuse. So according to SOHCAHTOA, we're going to be using the cosine for that. So the cos of 55 degrees equals x over 120. So x equals 120 cos 55 degrees. So see now, ladies and gentlemen, why we did trig initially to help us with this. Okay? So plugging that in our calculator, folks, we're going to have, hopefully, 68.8. Okay? So therefore, the horizontal component is 68.8 kilometers per hour. So basically all we're doing is doing SOHCAHTOA and finding either the adjacent or the opposite sides. All right, let's try another example here on the next page. Determine the horizontal and vertical components of each force. So the good news in this case, guys, is it gives us the interior angle. So I can simply drop this to make a 90. And again, y is my vertical component, x is my horizontal. Okay. So we can do horizontal first this time if you want. Okay, so looking at that, ladies and gentlemen, again, we've got the adjacent side, so we are going to use cosine. So cos of 75 degrees equals x over 40. Okay, x equals 40 times cos of 75 degrees. X should equal around 10.4. Okay, I'll do a therefore statement combining them this time. So for our vertical component, again, we're looking at the y. That's our opposite side with our hypotenuse. So that tells us we're using the sine of 75 degrees equals y over 40. Okay, y equals 40 times sine 75 degrees. Plug that in your calculator, and you should get 38.6. Okay, do a therefore statement. Therefore, the horizontal component is 10.4 meters per second for speed, and the vertical component is 38.6 meters per second. Okay, last problem today, gang. Here we go. Number 3, an airplane takes off with an initial velocity of 150 meters per second at 40 degrees from the horizontal. Determine the height of the plane after 30 seconds. All right. So first of all, we got to envision a plane taking off. So pretend that's at start, okay? It says that it's shooting off at 150 meters per second. Okay. It says that it makes a 45 degree with the a 40 degree angle with the horizontal. Okay. All we need to do, folks, is to drop a right triangle down, and then we have to ask or find out what the question actually wants us. It says determine the height of the plane after 30 seconds. Okay. So what we need to do is decide, do we need the horizontal or the vertical displacement? So what we need to do, folks, is get the vertical displacement, okay? So what we really want is y. So we're going to say let y represent the height of the plane. One thing we need to be careful here when we're doing this problem, guys, it's not just the height, it's the height after 30 seconds. So if we know we've got a velocity of 150 meters per second, what we need to do is times that by 30 seconds to get the total distance that it's gone, right? Okay, so times that by 30, which should give you 4,500. So total time is going to be 4,500 for that. Okay? All right. And that's just going to be meters. Okay? Because it's in 30 seconds. All right, so looking at what we need to do, folks, to find y, we're going to use the sine curve, sorry, the sine ratio. So the sine of 40 degrees equals y over 4,500. To get y by itself, it's going to be 4,500 sine of 40 degrees. Plug that in your calculator, and you should get 2,892.5 approximately. Okay. And then don't forget, because it's a word problem, to do your therefore. So therefore, the plane is 2,892.5 meters high after 30 seconds. Okay, let's just quickly summarize what we've learned today. So again, ladies and gentlemen, you can find if you're given the resultant, you can find the magnitude of the horizontal and vertical components using SOHCAHTOA. So for vertical, you're going to end up taking the magnitude of the vector and timesing it by the sine of the angle. Whereas to find your horizontal component, you're going to take the magnitude of the vector and times it by the cosine of the angle. All right. Here's tonight's homework, ladies and gentlemen. Page 48, numbers 1BC, 3AB, 8, 14, and 15. Have a great day. And again, see me if you need help. Ciao.